Today we're going to look at the derivative of y equals ln x, which is just y equals the log of x to base e. So it's a famous logarithm. It has its own button on the calculator. I just wanted to remind you of a few things. Number one, I posted a lesson on the review of logarithms. You need to look at that carefully to remind yourself of some of the basic principles involving logs. One big thing is to remember that a logarithm is just the reverse or inverse of an exponent. So if 2 to the 4th equals 16, then the log of 16 to base 2 equals 4. This is the base. Well, the one that we're going to be dealing with today, the exponential function / logarithm function that we're going to be dealing with today, is log of x to base e. So if the exponent function is e to the y equals x, then following the same process we did with this example right here, you can see that the log of x to base e equals y. And log of x to base e is called, it has a nickname called ln x, lnx, which is the natural logarithm. So we are going to establish the derivative of ln x here, and then we'll do several examples showing you how to apply the derivative. So here's what we do. Rather than first principles, we are going to take this expression and we're going to rearrange it into exponent form. Using this as our cue, we can say that y equals the log of x to base e, which means e to the y equals x. Then we take the derivative, since we know that if y equals e to the x, y prime equals e to the x. And we will do that with this one, but it is implicit differentiation. So if e to the y equals x, then the derivative will be e to the y itself times the derivative of y, its exponent is dy over dx, equals, and the derivative of x is 1. Rearranging, we get dy over dx equals 1 over e to the y. And if you look up here, there's a really nice value for e to the y. E to the y equals x. So the derivative is just 1 over x. If y equals ln x, then y prime equals 1 over x. That's a really simple derivative, and it's easy to apply. The laws of logarithms often make questions easier. Let's take a look at some of these examples over here. Y equals ln x. We just discovered, hopefully, that the derivative will be 1 over x, that y prime will be 1 over x. Here is a product, first, second. The derivative will look like this. Y prime equals first x squared times the derivative of the second, 1 over x. The derivative of ln x is 1 over x. Plus the second ln x times the derivative of the first, 2x. Let's simplify that. This part here with the x's canceling, you're left with x. Notice that the argument in the question, the argument for ln, is in the answer right here. 2x can't get multiplied into there. It's a coefficient, if you will. Common factoring, you get x 1 plus 2 ln x. X is a common factor. There's your derivative. Here's another product with trigonometry involved. Y prime equals first cos x times the derivative of the second, 1 over x, plus second ln x times the derivative of the first, negative sine x. So y prime equals cos x over x minus sine x ln x. And these don't have to be any particular order, but I'm going to write them that way. Certainly the negative should come in front. Let's keep going with a few more examples. They don't take very long. So here's a quotient. Let's use the quotient rule. Y prime equals denominator ln x times the derivative of the numerator, e to the 7x times 7, minus numerator, e to the 7x times the derivative of the denominator, 1 over x, all over the denominator squared. Let's simplify that out a bit. Y prime equals 7 e to the 7x on x minus e to the 7x all over x I didn't leave myself enough room to simplify that one, so I'm going to have to improvise here. First of all, we are going to multiply everything by x. Multiply this term by x, and this term by x, and this term by x, so that we can cancel those off. Where do I write that? Goodbye. Now we have y prime equals 7x e to the 7x ln x minus e to the 7x all over x ln x squared. And the last step will be common factoring out e to the 7x from the numerator. E to the 7x from the numerator, rather. Here's our first example with a complicated argument. So y is equal to the ln of 4x squared plus 7x. No longer is it just x, like it was in this example or the previous examples. So the way that we take its derivative is just say y prime equals 1 over whatever the argument is, 4x squared plus 7x, times the derivative of the argument. And the derivative of the argument is going to be 8x plus 7, just the derivative of the argument. So y prime equals 8x plus 7 over 4x squared plus 7x. Can't really remember what this example was exactly, so I'll make something up here. Y equals the ln of sine x. So this is an interesting derivative. Y prime equals 1 over the argument times the derivative of the argument. So y prime equals cos x over sine x. And there's an identity for that one. Y prime equals cotangent x. Our next group of examples involve using the laws of logarithms to simplify first. So make sure you do that review of the laws of logarithms and look at this. This is how we break them down. So if you have a quotient with exponents on it, etc., or a product, you can break it down like this. Ln of a squared over b cubed becomes 2 ln a. That's the down in front rule. And that should be minus, because it's a division, 3 ln b. And that's the down in front rule there. With that in mind, let's see how we can simplify this one before we take the derivative. As it is, it would be a hard question. You want to simplify it first. Y equals the ln of x squared plus 5. You can't use the down in front rule with that part because it's only on the x and not on the 5. And then minus ln of 3x to the 4th minus 7. And that makes the derivative taking really easy now. No quotient rule required. Y prime equals 1 over the argument times the derivative of the argument minus 1 over the argument times the derivative of the argument. So y prime equals 2x over x squared plus 5 minus 12x cubed over 3x to the 4th minus 7. I won't require you to find a common denominator, but at least we can factor out 2x from the numerator and get 1 over x squared plus 5 minus 6x squared over 3x to the 4th minus 7. Three more boards. 1, 2. This one does have an exponent on the outside, so I'm going to use the down and front rule. It would look like this. Y equals 4. This 4 belongs to both of them, so I'm going to put them in brackets. Ln x squared plus 4 minus ln tan x. So that's just using the laws of logarithms to simplify. You could distribute that 4 in if you wanted. I think I'll leave it in front and say y prime equals 4 times the derivative of this first part, 1 over the argument times the derivative of the argument, minus 1 over tan x times secant squared x. So we're going to simplify that a little bit. 4 times 2x over x squared plus 4 minus, let's see what identities will help us with here. Secant squared is 1 over cos squared x all over 1 over, all over sine x over cos x. So in that case, we'll multiply by the reciprocal. 1 over cos squared x times cos x over sine x. You get y prime equals 4 2x x squared plus 4 minus, canceling this cosine like that, 1 over sine x cos x. In our next example, we have a function, x times the ln of x, a product, and we want to find the tangent line at x equals e. So let's put e into the original expression. So y will equal e, the ln of e. Well, just to help remind you, ln of e really means the log of e to base e, and anything in that form equals 1. So you've got e times 1, so y equals e. So you've got a cool ordered pair, e comma e. Now let's calculate the derivative. Y prime equals first x times the derivative of the second, 1 over x, plus second ln x times the derivative of the first. So you've got a nice derivative here, 1 plus ln x, and then we want to put e in place of x. So at x equals e, y prime, the slope, is equal to 1 plus the ln of e. And we just spoke of the fact that the ln of e is equal to 1. So you get a really good slope, y prime equals 2. Let's put those facts into an equation of our line formula. Y minus y1 equals m onto x minus x1. Y minus e equals m onto x minus e. Y equals 2x minus 2e, and I'm going to transpose that to become a plus e. So y equals 2x minus e, and that's the equation of the tangent line at x equals e. Our last example is an implicit differentiation. Before I get started, I'm going to use my laws of logarithms to simplify the left-hand side. So we have cos of e to the y equals 2 ln x minus 3 ln y. So let's start taking the derivative of this one. The derivative of cos is negative sine of the argument times the derivative of the argument equals 2 times 1 over x minus 3 times 1 over y, but the derivative of y with respect to x has to be applied there. I'm going to take everything in this expression and simplify it, but I notice I've got x's and y's in the denominator, so I'm going to multiply everything by xy. So as I simplify it, I get this. Negative xy e to the y sine e to the y dy over dx equals 2y minus 3x dy over dx. So this x canceled with this x, this y canceled with this y. I'm going to transpose this term to the other side and get 3x dy over dx minus xy e to the y sine e to the y dy over dx equals 2y. And then we'll common factor out the dy over dx. And finally, we'll divide. 2y in the numerator. I notice there's a common factor of x in the denominator, so I'll take that out as well. 3 minus y e to the y sine e to the y. That's the end of our video. Make sure you watch it. Leave a comment so I know you were there.